what's going on, guys? In this video we are going to see how to prove this one using Archimedean property. Here this statement says for all x belongs to a real number if for all n belongs to natural number, x is less than or equal to 3 plus 5 over n, then x is less than or equal to 3. Okay, so we are going to prove this one using contrapositive. Contrapositive is basically we take the term that is coming after this then and negate this one and put it as first after if, and we negate this one and put it after then. So we just negate and switch this one. Okay, and if we prove contrapositive is correct, it means the statement is correct, because contrapositive and statement means the same thing. Okay, now let's go ahead and do the contrapositive. Contrapositive, first one doesn't change. For all x belongs to a real number, so after if everything is going to change. If sorry, this x is less than or equal to 3 should comes first. So if we negate this one, that's going to be x is greater than 3, and then whenever we have for all n, that if we negate that one, that's going to be there exists on n belongs to natural number, and this is going to be negation, so x is greater than 3 plus 5 over n. Okay, so now we got this one. The next thing is we are going to use the Archimedean property. Now let's look at the general form of Archimedean property. Archimedean property says when we have for all a comma b belongs to a real number, if a is greater than 0, then there exists a natural number such that n belongs to a natural number such that na is greater than b. Okay, so here we are going to do the same thing. First we have to bring this pattern to find out what is a, what is b, what is n, like n will be remain the same. We have to find out what is a and b. So we just have to grab this equation that is with this n and arrange this one in this format. Okay, if you arrange this one in this format, this is going to be x minus 3, and this n multiplies right here, and that is greater than 5. So from this one you can pick up this a, b values. A is what? A is x minus 3, the one multiplies n. A is equal to x minus 3, and b is equal to 5. So we can just by Archimedean theory, let's mention this one. We apply Archimedean property for a is equal to x minus 3 and b is equal to 5. Since x is greater than 3, then a is equal to x minus 3, that is greater than 0. Okay, x is greater than 3, so a is equal to x minus 3 should be greater than 0. Now we are going to apply Archimedean property. Now by I know this one from the statement. Okay, you always refer the statement x is greater than 3, then x minus 3 is greater than 0. That's how we got this one. Now by Archimedean property, we saw the property right here. This is the property. We are going to write that one here. This is there exists an n belongs to natural number such that na is greater than b, and we know what is a, what is b, so we just have to plug it right here. N times a is what? A is x minus 3. X minus 3 should be greater than 5. Now here we are going to use axiom number 13. Now let's see what it is. Let's get rid of these things. I'm going to continue somewhere here. Continue here. Okay, so we have this one. Now we are going to apply Archimedean property. We apply Archimedean property. We are going to use axiom number 13. You can refer that in the video in the description to see all these axioms. Okay, axiom number 13 says when you have two comparison, like when you have this one n times x minus 3 greater than 5, and like we also know n minus 1, n inverse is also greater than 0, because if n is greater than 0, n inverse also greater than 0. So in axiom number 13, what we do is we put opposite way, like we put always less, like 0 is less than n minus 1, and also we put 5 is less than nx minus 3. So here what you do is you multiply this one, and that is 5 times n minus 1 is less than, multiply this one, n minus 1 nx minus 3. So this is the axiom number 13. By axiom number 13 we get this one, by axiom number 13. Okay, n minus 1 is greater than 0. Okay, 5 is less than this. Yeah, we are right. And the next thing is this n should be outside of this one, because here is outside, and n inverse and n cancels each other. From this one we get x minus 3 is greater than 5 over n. Okay, now we are going to use the axiom number 12. Axiom number 12 says addition preserves order. It means whatever the value, if you add any value to both sides, it's still going to be the same. So for example, here what we are going to do is we are going to add 3 to both sides. X minus 3 plus 3 greater than 5 over n plus 3, because finally we want to prove x is greater than this one, right? When you add this one, this minus 3 cancels, and you will end up with x is greater than 5 over n plus 3, and that's what we want to prove. So we proved the contrapositive. If we prove the contrapositive, that automatically means this also correct. Okay, and that's how we like prove something using Archimedean property. I hope this helps. Thanks for watching, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.